All right, let's dive into something pretty amazing today. Underwater construction.
Underwater construction.
Building things like bridges and docks, but completely submerged. I mean, can you imagine the challenges with that?
You know, it's interesting because it's actually less about like fighting against the water and more about how to outsmart it.
Outsmart it.
Yeah.
Yeah.
Instead of, picturing divers struggling against currents, engineers have figured out how to essentially work dry.
Work dry underwater.
Yeah, dry underwater.
Okay, so I'm intrigued. How do they pull that off?
Well, it all starts with something called a cofferdam. It's basically a temporary watertight enclosure that's built right in the water.
Oh, so they're not actually like building underwater.
Not directly.
They're making the underwater dry first.
Exactly, yeah. It's like building a dry island for the construction site.
That is very clever.
Yeah.
Okay, but how do you build a wall, essentially, in the middle of the ocean?
Well, that's where these things called sheet piles come in.
Sheet piles.
Yeah, they're basically these interlocking steel sheets. Think of it like a giant Lego set for construction.
Oh, I see. Okay, so they interlock and then they create this wall.
Exactly.
Okay, but how do those sheet piles actually stay put, especially with, all the currents and the waves?
Right, that's where things get really interesting. They use these incredibly powerful machines called vibratory hammers.
I have a feeling it's not just like your average hammer.
No, not at all. These hammers have counter-rotating weights that vibrate the sheet piles.
They vibrate them.
Yeah, they vibrate them, and that shakes them deep down into the seabed.
So they're like shaking the ground.
Pretty much, yeah. It's pretty ingenious, isn't it?
That is very clever. Very, very clever. And I'm guessing like a solid understanding of the ground is crucial before they even start like hammering anything.
Absolutely, yeah. Before any of this happens, they do these extensive geotechnical surveys. I mean, imagine building a skyscraper on shaky ground,
That would be a disaster.
That'd be a recipe for disaster. It's the same principle underwater.
So how do they actually like figure out what's going on beneath the seabed?
Right. Well, one way is this thing called the cone penetration test.
Cone penetration test?
Yeah, it's where they basically push a cone-shaped probe into the ground.
Okay.
And they measure how much resistance it meets. So this tells them things like the soil strength and the depth of the bedrock, which is crucial information.
So they know how deep those sheet piles need to go.
Exactly.
Okay, that makes a lot of sense. But then what happens once you've built this like giant underwater wall?
Right. Well, then it's time to drain the pool. So they pump out all the water inside the cofferdam, and that creates that dry environment.
So you have a dry environment underwater.
Yeah, essentially. But of course, now you've got a whole new challenge. You've got water pressure.
Oh, yeah, I can imagine the surrounding water's pushing pretty hard against the walls of this cofferdam.
Absolutely. And if they're not careful, that pressure could actually cause the walls to buckle inwards. So to prevent that, they use these elaborate bracing systems inside the cofferdam.
So almost like a skeleton holding it all up from the inside.
Exactly. They use beams and struts and tie rods. It's like a whole network of support to withstand all that intense pressure.
That's amazing. And sometimes they even use double-layered cofferdams.
Yes, exactly.
With fill material like sand and gravel between the layers, right?
Yeah, that's right. Just for that extra strength and support.
So they're really taking every precaution to make sure the cofferdam is secure. But I mean, with all of that, can't water still like sneak in?
You're thinking about seepage.
Yeah.
Yeah, and that is a constant battle in underwater construction. They have to have pumps running 24/7 to remove any water that seeps in.
It's just a constant game of keep the water out.
It is, yeah. It's a constant battle.
So is there anything else they do to combat this seepage?
Yeah, so one crucial thing is they actually build a cement seal right on top of the bedrock underneath the cofferdam walls.
So that stops the water from coming up from below.
Exactly. It's much tougher for the water to get through.
Wait, but how do you pour concrete underwater to make that seal? Doesn't it just like dissolve and become useless?
All right, well, that's where a special technique comes in called the trimmy method.
Trimmy method.
Yeah. Essentially, they use a special pipe with a plug at the bottom.
Okay.
And they lower this pipe down to the seabed, and then they pump the concrete down through it.
Oh.
And that plug keeps the concrete separate from the water until it reaches the bottom, so you end up with a nice solid seal.
Ah, I see. So they've gone to all this trouble. They've essentially created a dry, stable construction site, meters below the surface. What happens next?
Well, now the real work can finally begin. Within that protected space, they can start building whatever structure it is that's planned,
Okay.
whether it's a bridge pier or a tunnel section or, even the foundation for like an offshore wind turbine.
That's incredible. And it all starts with that temporary island, that cofferdam.
Yes.
It's almost like a key that unlocks the ability to actually build underwater, using a lot of the same techniques that we use on land.
Exactly, yeah.
That's amazing. But what happens to the cofferdam once the structure is built?
Now, that is a great question. And it kind of leads us into the next fascinating phase of this whole process. So, in a lot of cases, they actually remove the cofferdam once the construction is finished.
Oh, wow. They take it all down.
Mm.
Seriously.
Right.
Why go through all that effort just to take it down?
Well, there's a few reasons. I mean, for one thing, imagine if they left this giant steel wall surrounding a bridge pier.
Yeah, it would be kind of an eyesore. It wouldn't be very aesthetically pleasing.
Exactly, yeah. And not just that, leaving it there could actually disrupt the natural flow of water around the structure
That's true.
and potentially affect its stability over time.
Yeah, that makes sense.
So yeah, they carefully dismantle the whole thing.
How did they do that?
Well, they cut the sheet piles below that cement seal we talked about earlier.
Oh, right.
That way it ensures that the structure's foundation stays intact. But it makes you wonder, though, like, why even bother with this whole cofferdam thing in the first place?
Yeah. Wouldn't it just be easier to, design structures that can be built entirely underwater?
Right, that's a great point. And it really highlights the ingenuity behind this approach.
Okay.
You see, building a cofferdam lets engineers use a lot of the same tools and techniques that they use on land, even though they're working underwater.
So it's like they're bringing a bit of dry land to the construction site.
Exactly, yeah. And this approach has actually been used to build some pretty impressive structures throughout history.
Oh, really? Like what?
Well, think about ancient Roman harbors, for example.
Wow. So this isn't just like a modern technique.
No, not at all. Underwater construction has a really long history and a fascinating one.
Oh,
From those ancient piers and breakwaters to, modern day tunnels and pipelines, it's played a really vital role in shaping the world around us.
it's incredible to think about all the innovation, all the problem solving that's gone into it over the centuries, just driven by that need to build beneath the waves. What's next? What do you think the future holds for underwater construction?
Ooh, that's where things get really exciting. I mean, just imagine things like underwater cities.
Underwater cities.
Yeah. Or, floating farms, maybe entire ecosystems engineered to thrive beneath the surface.
Hold on. Are you being serious right now? Underwater cities.
I am, yeah. Think about it. We're facing all these challenges with rising sea levels and population growth.
Right.
Underwater construction could offer us some really innovative solutions for things like living space and food production.
I mean, it sounds like something out of science fiction, but maybe it's not as far-fetched as we think.
Mm-hmm.
What kind of, advancements would need to happen to make those underwater cities a reality?
Well, we're already seeing some incredible progress in areas like robotics and automation and new materials.
Okay.
Imagine things like underwater drones inspecting structures for damage. Or robots assembling these complex components, deep beneath the surface.
It's almost like there's this whole new frontier of construction opening up before our eyes.
Yeah, and with this growing need for sustainable solutions, I think underwater construction is going to play a huge role in shaping the future. But there's one thing we haven't really touched on yet,
What's that?
the environmental impact.
Oh, yeah. I mean, that's a big concern.
It is, and it's something that engineers take very seriously. Any underwater construction project has to go through a very careful planning and assessment process to minimize its impact on marine life and ecosystems.
So it's not just about building impressive structures, but doing it in a way that's responsible and sustainable.
Exactly. And it's a challenge, for sure, but one that engineers are constantly working to address. They're developing new techniques and materials that are both durable and environmentally friendly.
So there's a lot of responsibility that comes with building underwater.
There is, yeah.
But it's also an incredible opportunity to really innovate and find solutions to some of the biggest challenges facing our planet.
I couldn't have said it better myself. Now, before we wrap things up completely, I want to shift gears just for a moment and talk about something that I find particularly fascinating: the human element of underwater construction.
The human element. Okay. What do you mean by that?
Well, we've talked a lot about the technical aspects, the engineering behind it all.
All right.
But behind all that, there are these incredibly skilled individuals who actually make it happen.
Oh, right.
The divers, the welders, the crane operator, they're the unsung heroes of underwater construction.
That's so true. We tend to focus on the structures themselves. We rarely think about the people who, you know, risked their lives to build them.
Exactly. And these individuals are working in some of the most challenging and often dangerous conditions imaginable.
Yeah, I bet.
I mean, they're facing extreme pressure, limited visibility, the constant threat of unpredictable currents. It takes incredible skill and courage and a really deep understanding of the underwater environment to do this kind of work.
It's really a testament to human resilience, I think.
Yeah.
Our drive to push the boundaries of what's possible.
It is, and their stories are just as fascinating as the structures themselves.
No, I bet.
There are tales of daring rescues and ingenious solutions to all these unexpected problems,
Right.
and there's a real camaraderie that you find among these people that's forged in the face of danger.
Wow. I'm starting to see a whole new side to underwater construction. It's not just about the steel and the concrete. It's about the human spirit of exploration and innovation.
Precisely. And as we continue to explore the vast potential of our oceans, I have no doubt that that human element will continue to play a crucial role.
Yeah, this has been such an eye-opening journey for me. We've gone from the technical intricacies of cofferdams to the historical significance and the incredible potential. And now, with this newfound appreciation for the human side of it all, I'm even more eager to see what the future holds.
Me too. It's a field that's constantly evolving, pushing the boundaries of what we thought was possible. And as we wrap up this deep dive, I'd like to leave our listeners with one final thought. Well, we've explored the hows and the whys of building underwater, but what really sticks with me is just the sheer ingenuity of it all. It's not just about conquering the water, it's more about working with it, almost like collaborating with nature to achieve these incredible feats.
Yeah, it's amazing what they can do. And you mentioned earlier those underwater cities. That concept really blew my mind. What other possibilities are out there? Like, what could we achieve if we could really harness the power of the oceans to build not just structures, but like whole habitats or even ecosystems?
It is pretty mind-blowing to think about. Imagine underwater research facilities powered by ocean currents or sustainable aquaculture farms that are integrated into offshore platforms.
Mhm.
Or even, artificial reefs designed to revitalize marine life. The possibilities really are endless.
It's incredible. It seems like we're really just scratching the surface of what's possible beneath the waves. And with everything that's going on, the urgency to address climate change and protect our oceans, it seems like underwater construction could play a pretty key role in shaping a more sustainable future.
Absolutely. And for our listeners who are feeling inspired to learn more, there are some fantastic resources out there.
Yeah, like what?
Well, documentaries like Oceans Apart and Deep Sea Challenge, those offer a really amazing glimpse into the world of underwater exploration and construction.
And are there any good books?
Oh, absolutely. For those who prefer reading, there's The History of Underwater Exploration by Robert F. Marks.
Okay.
It's a classic. It really delves into those fascinating stories of the underwater pioneers, from the ancient divers to the modern-day aquanaut.
Oh, cool, cool. And what about like websites?
Oh, don't forget those online resources. Those are great too. Websites like the Society for Underwater Technology and the Marine Technology Society,
Right.
they offer a wealth of information on the latest advancements and innovations in the field.
Perfect. We'll be sure to include links to all those resources in the show notes for everyone. So next time you see a bridge spanning a vast strait or catch a glimpse of an offshore wind farm, really take a moment to appreciate the ingenuity and collaboration that made it possible.
It really is a testament to human innovation
It is.
and our evolving relationship with the ocean.
This has been an incredible deep dive. I feel like we've covered so much ground today. Starting from those technical intricacies of the cofferdams to the historical significance and the incredible potential of it all. And now with like this newfound appreciation I have for the human side of underwater construction, I'm even more excited to see what the future holds.
Me too. It's an amazing field, and it's constantly evolving, pushing the boundaries of what we thought was possible.
Well, thank you so much for joining us today. It was a pleasure having you on.
It was my pleasure. Thanks for having me.
And to all of our listeners out there, until next time, keep your curiosity alive and your eyes on the horizon. There's a whole world waiting to be explored both above and below the surface.